Okay, folks, tell me what's wrong with this big, large solar panel and the law called Ohm's Law. Okay, we're on this voltmeter here, this ammeter, set at the 10 amp scale. Alright, we're reading right about 0.3 amps with sun changing currently. Sun's getting dimmer. 0.3 amps is about what it's supposed to be. So what we're going to do, we're going to switch out to how many volts are being supplied. Okay. 17.8 volts, 84 volts currently. The sun brightened up a little bit. Okay, so now let's describe that as a law. Ohm's law is directly proportional. So you have to think that the output is the same. The output is in the same location. So if it has 17.84 volts and only 0.3 amps, then something isn't right. Which means that there has to be a resistance somewhere that's blocking the amperage. And it had diodes installed across it, bridged across it. So like, basically, there is an amp reduction. So if we look, we call this theory current adds or current reduction. Okay, so we have two diodes connected to the same place in a certain direction. So current is actually flowing across that point with diodes flowing in the same direction. Okay, so technically current is on that center post, and in one direction on the left is the positive. It cannot flow back to the center. However, the center post, the post on the right is negative, and it can flow to the center because the center, if the center is positive. So essentially what you have is current flowing to the center, and positive is flowing to the center. So at the center there is a circuit being positioned. So the diodes technically are probably like radiating or something. They're generating, well, if you see the lines on the diodes, the positive to the left, that's correct. The line is to the positive on a diode. The line is to the positive. So in the middle should be the negative. However, the other diode on the right is saying that it is a positive, which means it flows directly through, okay? Flows directly through, and it will allow the negative on the other side to flow all the way across to the positive, while the center post is nothing more than a part to some part of probably a positive, which means it's actually short-circuited, or supplying power to some part of the solar panel. It's supplying power to the solar panel. Otherwise, it's short-circuited. So, what does that actually mean? We're not certain what that actually means. That could just be the center trying to connect between the cells, where it bridges positive to negative, and then it also can't flow to the positive. So the positive is actually always positive on the left. So what do you do here? Essentially, we really need to disconnect the diodes. It doesn't make sense that these diodes are connected here. It doesn't seem to make any sense. And what we can do is break out our handy dandy snips. What we can do is break out our handy dandy snips, cut it right in the middle. Alright, we cut that diode. Let's cut this diode too. Both diodes are cut. Now, let's test the voltage on the positive and negative leads. Okay, we have 15.3 and the sun went down. There's a cloud. Okay, so those diodes were never meant to be hooked up on the main voltage. It was 18 volts. So, we just got major clouds outside. Big cloud passing. So it died down, so that reduced it by 3 volts. So, those diodes were never meant to be connected. So, we had to cut them off. So what we're going to do is we're going to leave those diodes disconnected. We also have a solar panel in here. we don't know how to disconnect our case here. We also have diodes here on these, and we're also going to clip them on the center. We clip those diodes on the center too. So we don't want any diodes connected. We're leaving that out. So we're good there. So now let's test the amperage to see if there was a current add property. Current reduction, current add. So let's take our two posts and see what the amperage output is now. Oh, I have to change it to 10 amps first of all. Okay, so now we have 0.06 amps. Okay, that is an extreme reduction in amperage. So why did it do that? We don't know. That's the voltage was 15 volts with less sun, and the amperage reduced significantly when we cut the diodes. That has something to do with the resistance of the cells probably. So in this case, I want to tell you that Ohm's Law is a tricky sucker. Okay, in this case of the solar panel. Ohm's Law doesn't work the same. Okay, the voltage is there, but the amperage is not. That means Ohm's Law does not work. Okay, something is reducing the flow of energy, but still saying that it's there at the same time. Voltage is energy. Resistance is the resistance, the impedance of energy. Okay, and amperage is the flow of electrons when you apply energy to a resistance. And that's what's happening, is that the proportionality should be much higher based on the resistance value of something that is charged. So technically it should be charged, but technically it's not. It's saying that it has very low amperage. So basically we got to find a way to say that the voltage is high and the amperage is low, which means there's a resistance problem in the circuit of this solar panel. So Ohm's Law is doing something very tricky in this solar panel. So I don't validate Ohm's Law, but at the very terminal point of 15 volts, you should automatically have whatever resistance you hook up to that 15 volts should automatically have, based on the resistance values, a proportional amperage value to the voltage. Okay, based on how much amperage is being resisted. So it should automatically be, if I hook up 2 amps to these 2 terminals right there at that block, 2 ohms, if I hook up 2 ohms to these terminals in the form of copper wire, which is running out, it should automatically be, according to the proportionality of Ohm's law, it should be 8 amps. But what we read is that there are hardly any amps, like 60 milliamps is what's coming out of that thing. That is too low. Amperage is very important. If amperage doesn't flow, your circuit is very weak. If you have a high voltage with low amperage, it is a very weak circuit. And the voltage is actually a lie, because it's being mismeasured. So that invalidates these voltmeters and actually invalidates Ohm's law if these voltmeters are telling the truth. So one or the other, either the voltmeter is lying about the voltage or Ohm's law is false. Which one is it?